And so the way we're going to look at the trigonometric functions is going to be where we're going to plot the argument of the, let's say, talk about sine function. If we take y equals the sine of x, we're going to plot x versus y the way we would with any function. So it's not going to be this circular function anymore, or this circular diagram. It's going to kind of unwind into this what's called a sine-shaped curve. And so, in essence, what we're going to do is take our unit circle, and as our angle increases by going around the circle, we're going to just plot it out on a straight line, and then we get this curve that starts. The sine of 0 starts at 0, 0, and then it goes up to 1, and then it goes back down to 0 when you're at 3/2 pi. And so what you're going to get then is something that looks like this, and it'll go on repeating. Now, remember the domain of the sine is all real numbers, right? We can take a very large number, or take a negative number, whatever we want. It's periodic, so we're going to see this kind of cycle of it going up and down indefinitely, and it'll go back and it'll go forward. And so we'll deal with a couple terms here. When it takes the full cycle, so this is just going to be the sine of x. The sine of x goes back to 0 at, of course, at pi, and then at 2 pi, it's going to start all over, and the next cycle is going to look exactly like this. So we call that the period, and the period of the sine function is 2 pi. Okay, so then it's going to go up and down, and I'm going to cross out that 1, and I'm going to call this a and negative a. So from the x-axis up to the maximum value is going to be the amplitude, and here the amplitude is going to be always a positive number. So even if we take this thing and start with a negative curve and then going up positive, we're always going to call the amplitude positive, because the amplitude, what we're asking for is the size of something, and so whenever we talk about size, we're looking at positive values. Okay, so if I have something that looks just opposite, where if this first one is y equals a times the sine of alpha, this next one, a sine of alpha, is going to be what it looks like when a is less than 0, or when it's negative, right? If we have, let's just say negative 1 is going to be the easiest case. So it's going to actually start out where when you have the sine of pi over 2, that equals 1, and then 1 times negative 1 is puts that value down there. So your sine, can either be a curve that starts up to a positive value, or if we have a negative coefficient in front of it, it starts heading down and then back up. But in either case, we call it the period 2 pi, because that's when it makes one complete cycle and starts repeating itself. Okay, so now what we're going to do is we're going to start moving this thing around. And I'm going to build this up kind of step by step. The coefficient in front of sine, you can see that is just the amplitude. So if that was, instead of 1, it was a 2, 2 sine of x goes from 0 to 2 to 0 to negative 2 and back and forth. We can also put a vertical shift on this. And just like we did with the graphs before, where we would just essentially add a number to an existing function, we would expect that the whole graph would go up. And so if this is our sine, all right, then we would expect y equals the sine alpha plus d. We would raise the whole thing up for d, and then it would cycle about that d plus or minus the amplitude a. So the whole sine moves up, and so depending on the size of d and the size of a, you could always get positive values, or you can always get negative values, or you can get mostly positive and some negative. This thing can move around up and down pretty much at will. So you can make it taller or shorter, and you can move the whole thing up and down with A and D. Okay, so in electronics terms, they call D the bias, B-I-A-S. And in most math books now, they're not using bias anymore, because bias in electronics used to be something really important with vacuum tubes. And of course, unless you're a guitar player loving vintage amps, you don't see vacuum tubes anymore. And so, so the name bias has kind of dropped off of that, but just historically, that's what it's called. Okay, everybody with me? Okay, so now let's put a coefficient in front of the x. So now we have the sign of bx. And instead of that alpha, we have a bx now. So what do you suppose happens with b when we put a b in there? It's going to stretch or compress the x-axis, right? So let's look at 5 key values. And this is a little bit different than your book takes it, but I think it's by far the easiest way to graph functions, is that with sine, there's 5 key values, right? At 0, the sign is 0. At pi over 2, the sign is 1. At pi, the sign is 0. At 3 pi over 2, the sign is -1. And at 2 pi, the sign is 0 again. So let's look at these 5 points, because realistically, if you put them on a graph, then you can pretty much eyeball the curve if you go through from 0 to 1 to 0 to -1 back to 0. So I'm going to really key on these 5 key points. Okay, so what would x be in terms of b then? It would be the pi over 2b instead of just pi over 2, pi over b, 3 pi over 2b, and 2 pi over b. So what would you expect the period to be then? So if we did nothing to it, we would just have alpha, we'd have 2 pi. So the period of bx, what would that be? 2 pi over b, right. And so when we calculate the period, that's what we're going to do. We're going to take that coefficient and take 2 pi divided by that coefficient. Okay, so here's our period. And so if we were to make this graph, now here is where I'm going to cheat a little bit in making my graph. I'm going to draw my sine curve before I put on the scale. And so I know my period if I have sine of 2x, if I take 2 pi over 2, I know my period is pi, so I'm going to be back at 0 when x equals pi. And you can put that in, just put that in as well. If x equals pi, then the sine of 2 pi is 0. Or if you take pi over 2, which is this point, times 2 would be just 2 times pi over 2 is just pi, which is 0. So we're able to essentially change the scale here rather than put a scale down and try and fit the curve to the scale. You know, I mean, a sine curve, whether you stretch it or contract it, you know, it will change kind of its appearance. You know, it'll flatten it out a little bit. But still, if you make the scales essentially the same proportions, you get sine looking exactly the same. So here we have the period now. Okay, so what I want you to do is I want you to graph this. And I'll pass out some graph paper. I made a comment on some of your homework to focus on making your graphs a little more neat. And now it's going to be crucial, especially putting scales on it, because what the x-axis, how that's labeled, is going to be essential in making this graph. So go ahead and make this. This will take a little few minutes. Now that's a fancy notebook. Pen. Right?
Yeah, I just have.
Okay, so the first thing is that we look at that, that vertical shift, okay, and that's -1. So we know that this thing is going to cycle above and below this dashed line at -1. And then we also know that our amplitude is 3. So we're going to be 3 above -1 and 3 below -1. So our sign is going to be in between those two bounds. So now here's where I'm drawing my 5 points. You see, I know that I'm going to start at 0. I'm going to go up to 3, or 3 minus 1, which is 2. And then when I'm halfway through my cycle, I'm going to be at -1, because 3 times the sine of whatever that is to give me a 0. Then I subtract 1. And then down here is my 4th point, where I'm 3/4 of the way through my period. And then this point is actually here. It's not up at the axis. I guess I should have indicated that. Let me make an adjustment there. So we're really talking about this point there. So those 5 key points that I'm talking about, there's one here, there's one here, there's one here, one here, and one there. So kind of when we have those 5 points settled, we can draw our curve. Now, notice I didn't label what that axis was, because what I'm doing is I'm first calculating the period. Okay, so the period was 2 pi over b, and in this case b is 2 pi. So the period is 2 pi divided by 2 pi is 1. So you're going to expect this value here to be 1. And then this one would be, the halfway point would be 1/2 of that, which is pi over 2, or not pi over 2, it's just 1/2. Then this one's going to be 3/4, and this one's going to be 1/4. So I write those in, and I'm done. So not every horizontal scale is going to have pi. If I have pi in my function here, that means that x is going to not have a pi in it. So here are my points. So I could write what these coordinates are. So these are 0, -1. This one is going to be 1/4 and 2. This one here is going to be 1/2, -1. This one is 3/4, -4. And then this point is 1, -1. Yeah.
How did you get the points on the x-axis again? I missed it.
What I did was I found this here. My period is the last point, and so I'm going to calculate what my period is, and it's 1. So then it's going to be 1/4 of the way each time for these 5 significant points. Okay, since I calculated my period to be 1, then I know that I'm going to be at this point where it crosses over my bias at 1/2 of whatever this was, and since this is 1, it's just simply 1/2. And then this is 1/4 of the way, and this is 3/4 of the way. Okay, before we get to the next step then, do you want to do another one? Shall I just write another one on the board and you can see what that one is? Okay, so let's do y equals, I'm I'm going to leave off the D and the A and just call this the sine of x over 2. Okay, so graph that. So there's no vertical shift, the amplitude is 1, and so what you do is you calculate the period and draw the sine curve in using the period. So we can make a horizontal shift. Remember when we had just, let's say, f at x. If I'm going to make a new function out of f at x by adding something to my x before I do anything to it, we can do the same thing with sine by adding this c. And what we're going to call this horizontal shift is a phase shift. Okay, so this is another term that comes from a lot of different fields in science. Electronics is one, but also, you know, when you think about the cyclical nature of sine, we always can talk about what phase are you in or what part of the curve are you in. So we can do this horizontal shift or shift the phase by adding on this c. And so let me give kind of a similar thing. We're not going to worry about b right now, okay? We're going to look at just x minus pi over 4. So the period stays the same. It doesn't matter if we shift the graph left or right. We're still going to have the same kind of distance from 0 to 2 pi or between any 2 points to get one full cycle. So our period is still 2 pi. But what happens to x? If we want alpha to be 0, what does x have to be in order for that expression alpha to be 0?
Pi over 4.
Right, because then you have pi over 4 minus pi over 4. And so if we add pi over 4 to each of those values, and this is where you get really good at, you know, adding up fourths and halves and reducing fractions and things. So pi over 2 is 3/4 pi. So if I were to stick in, let's say, this 7 pi over 4, and I stick it into this expression here, I get 7 pi over 4 minus pi over 4 is 6 pi over 4, which is, then alpha becomes 3 pi over 2. So remember, these are these points that I'm really interested because the sign gives me nice clean values for. I'm not noodling around with things like square root of 2 over 2 or anything like that. I'm dealing with 0, 1, and -1. So these are the values that will correspond to giving me a sign value of 0, 1, 0, -1, and 0. So if I draw this, I'm going to start at pi over 4. And because if I stick in a pi over 4, I'm at 0. If I stick in a 3 pi over 4, subtract pi over 4, I get my 1 at 3 pi over 4. 5 pi over 4 minus pi over 4 is just pi, so you expect that to be 0. 7 pi over 4 and then 9 pi over 4, and you draw your curve. Okay, so I have shifted the phase. I have moved this thing like dialing a knob or something. I've shifted a phase over to the right by pi over 4. And that corresponds to, remember when we were dealing with functions in general, this shifts things to the left when c is negative, in this case negative pi over 4, it shifts it to the right, and we see that this whole curve shifts to the right. And you're thinking, how many more of these are we going to have? This is it, actually. Okay, y'all up with me with your notes? Okay, so let's look at the overall scheme, what I've laid out. So the 4 possible things we can do is A, B, C, and D. And so we're going to take the absolute value of A as the amplitude, and that's that's how far out of the center it goes. 2 pi over b is the period. That starting point is going to be negative c over b. Now, I didn't exactly explain the role of b in that horizontal shift. We'll see this in the examples, why that has to be negative c over b and not just c. So in this case, in the example that I just gave you, b was 1, so the starting point is negative pi over 4. So that was pi over 4, which was our starting point. And then the vertical shift, I think that one you probably all have grasped now. Okay, so this is the procedure on how we're going to graph general functions of sine. So we're going to calculate these 4 values first. Okay, so you say, okay, amplitude is this, period is that, starting point is this, vertical shift is that. Okay? And then what we're going to do is we're going to find the points at the starting point and at 1/4 increments of the period for those 5 key points. So in other words, I want to find from my starting point, I want to add the period, but only 1/4 of it to get to this first point, another 4th here, another 4th here, and then another 4th here. So ultimately I'm adding the period to the starting point to get to where I'm going to end that one cycle. And then we can find the y values just by taking those key points, you know, the 0, 1, 0, -1, and 0. We multiply it by our amplitude and add d to it, so we get the y values that we're supposed to plot. And then once we have those 5 points, we can eyeball the curve through there. Okay. So let's say I want to plot this. I'm going to first calculate those 4 points. My amplitude is 1. My period is going to be what? What's the period on this one?
4, 5, 8.
How did you calculate that? Think about the definition of the period. It's 2 pi over b. And what does b equal? It equals pi over 2. And so we get 2 pi over 2 is the same thing as 2 pi times 2 over pi, which is 4. So you have to be careful on how you treat your fractions here. You know, you multiply by the reciprocal. So there's the amplitude, there's the period, where's the starting point? Starting point is going to be minus c over b. And so when I do that, I get -1/2 as my starting point. So what this means is, since I'm going to start in a negative value, I'm shifting the graph to the left. And that, of course, intuitively should work, because when I add that c, it's going to move to the left, right? And so this is how much I'm going to move it to the left, and that's 1/2. And so I'm going to divide my period into 4 to get these 1/4 increments. Like here, when my period was 4 pi, I divided into 4, so I get pi, 2 pi, 3 pi, and 4. So I'm going to start with my starting point, and then I'm going to add 1, which I got from dividing the period by 4, and I'm going to complete those values. So here are my 5 key values that when I plug those things in into that expression for alpha, I'm going to get my familiar 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we can do that. So if we say -1/2 times pi over 2 will be -1/4, or negative pi over 4 plus pi over 4 gives us an alpha of 0. If I take my 1/2 and multiply that by pi over 2, I get pi over 4, so these two, pi over 4 plus pi over 4 is going to be pi over 2. I'll take my 3/2 here. 3/2 times pi over 2 is going to be 3 pi over 4, plus pi over 4 gives me 4 pi over 4, which is pi, and so on, all the way until I get down to 2 pi. And so what are my y values now? Well, it's simply going to be, my amplitude is 1, and I'm not doing any kind of a bias on it, so those will be my key points. And so when I plot this thing, I should go in increments of 1/2. My starting point is negative 1/2, and then what I'm going to do is plot all these x values, and I'm going to plot the corresponding y values with those. So my points will be those 5. Okay? So let me write these, those things. You want the amplitude. Let's say y equals a sine bx plus c plus d. So the amplitude is the absolute value of a, and then the period is going to be 2 pi over b. All right, and then we're going to have the starting point is going to be negative c over b, and then my, what's the fourth one? Yeah, the fourth one is going to be the up and down shift, okay? So the vertical shift is going to be d. All right, those are the 4 things to remember. And so what I'd like you to do now is you're going to try doing this one now. Okay, so this one doesn't have a b, it doesn't have a c, so this is just the sine of x, but we're going to multiply by 2 and subtract 1. So we're going back to one of the earlier cases. Okay, and Frankie, when you're done, will you draw it on the board?